Another way of approaching the identities is to do expansion of the terms and be able to compare terms by term and coefficient by coefficient, right? So that's the second approach. We are not going to be doing the cover up rule, but we are going to try to compare terms on both sides. How is that thing done? What you do is that you focus on this side, right? Focus on this side, you expand it fully, you group like terms, and then you compare the coefficient of each term, right, with its corresponding component on the other side. Let's do it. So we are going to focus on this side, like the left hand side, and expand it. So a times x, that will be ax plus 2a, right? Plus this one will give me bx minus b. So this is equal to a and b. That will be like a plus b. We are grouping like terms x, that's the x components, this and this, right? Now we group the constants, so these guys two are constants, plus the constant are 2a minus b. These guys are the constants. And when you come here, we have 2x squared plus 3x plus 1. So this is a constant. This is the term in x, and then this is the term in s squared. But we don't have any term in s squared, so it's fine. But the term you have here is a plus b. So you know that a plus b over here, that term over here should be identical to the one that is beside x on the other side. So here it is x, right? The entire term is a plus b. This is the coefficient here. If they are identical, then whatever term that we have here, a plus b, is supposed to give us whatever we will find at the coefficient 3. So it's equal to 3, right? And the constant 2a minus b, the constant here, because it's not having anything attached, right? It's going to be the only constant here. The only constant we have here is 1, right? So if you don't have a constant here, that will be 0. So fine. So what we do is that we solve for this. So if I do this, I can say a is equal to 3 minus b, right? Then I can put this value of a into this. So I will have 2a, 2a is what? 3 minus b now. 3 minus b. Sorry, let me clean it. Let me select this one, move it here. Select this one. I mean, this entire thing is not coming. So let's select them like this and move them here, right? So this is it. So I'm going to put this inside this. So I have 2 into bracket 3 minus b, because this is the new value of a. A is equal to this, right? Minus b equals to 1. So I'm going to have what? So this one will lead me to 6 minus 2b minus b equals to 1. So I have 6 minus 3b is equal to 1. So negative 3b is equal to 1 minus 6, that will be negative 5. So b is equal to 5 over 3. So if b is equal to 5 over 3, then let me clean this side so we can have more space. If b is equal to 5 over 3, then we need to put back that value of 5 over 3 inside this, right? So we know that a is equal to 3 minus b, and then our b is equal to 5 over 3, right? So we put it inside. So a is equal to 3 minus 5 over 3. So if you do this, we are going to have 9 minus 5 all over 3, which will give me 9 minus 5, that will be 4 over 3. So a is equal to 4 over 3, b is equal to 5 over 3. These are the two answers from the expansion and comparing like terms. Let's go with this one. This one too, we do the expansion. So I'm going to expand this side, right? So I'm going to have ax plus 3a plus bx plus b. right? Grouping like terms is going to be a plus b x plus the constants are 3a plus b. The constants don't have any x term with them. That's what we call the constants. So we are going to compare. So we don't have any term in s squared, so this guy will be out. But then we know that there's a term in x, right? That's a plus b. So a plus b, the coefficient should be equal to the total coefficient beside the x, which is 4. And also the constant 3a plus b should be equal to 5, because this is the constant, should be equal to the constant on the other side. So if you do this, we know that a is equal to 4 minus b. So you put in the value of a here. You're going to have 3 into bracket 4 minus b plus b equals to 5. I'm just putting this new value of a into this equation to get this. So if you have that, we are going to have 12 minus 3b plus b equals to 5. So if you continue this, you are going to have negative 2b on here over 5 minus 12, that will be negative 7. So b is equal to 7 over 2, right? But we know from this equation a is equal to 4 minus b, which is the same as 4 minus 7 over 2. So a is equal to 8 minus 7 over 2. So a is equal to 1 over 2. This is the value of a. Another question, we need to do the same thing, expansion, right? We expand this side, we have ax plus 4a plus bx minus 2b. So if you group like terms, you are going to have a plus b, which are the like terms, right, equals to negative 1, because the coefficient are as beside x is negative 1. And then what else do we have? The constants, right? The constants are 4a minus 2b equals to the constant here is negative 2. Negative 2. So we from here we know that a will be equal to negative 1 minus b. So I'll put in the new value of a inside here. I have 4 into bracket negative 1 minus b be equal minus 2b equals to negative 2. So if you do this, we are going to have negative 4 minus 4b minus 2b equals to negative 2. So let me move here and see if I can have some space. So we have um, negative 4 negative 2, that will be negative 6b, and negative 4 goes to the other side, it becomes 2, because negative 2 plus 4, that will be 2. So we have b is equal to negative 2 over 6, which is equal to negative 1 over 3. So that's the value of b. Now we know the value of b, so we are going to put the value of b inside this. So a is equal to negative 1 minus 1 over 3. That will be negative 3 minus 1 over 3. That will be negative 4 over 3. So the value of a is equal to negative 4 over 3. So these are the two values of a and b. So try this particular method on this and compare the coefficients. Let's see how far you can get and the response that you get.